Hello all, welcome to the video lecture series for the subject compiler design. Now I am going to explain you people about converting a regular expression directly to DFA. There are many regular expression conversion directly to DFA. I have choose something interesting and also very easy method where you can directly convert a regular expression to DFA. So this is the method I have chosen. So any given regular language can be converted into RE, that is a regular expression, and RE to NFA, NFA to DFA, DFA to minimized DFA. This is the final part we are going to achieve. Right. So I have taken an example here. Construct DFA for R is equal to 1, 1 plus 1, 0, the whole star. So as you all know, by reading this input, there is a concatenation, there is an union, and there is a closure. So let me take you to the conversion of RE to NFA. By projecting this particular diagram, you can choose any number of states, but here I have chosen only 9 states, totally in 10 to complete this regular expression conversion into NFA, right? I started the step name as 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 is the end state, right? So let me take you to the starting state 0 here. So I need to pass 1, 1 plus 1, 0, either 1, 1 or 1, 0, right? So here I have taking the 0 to reach 1 by using the epsilon. As you all know, this is a null transaction. So you can use this to jump from one state to another state without passing any original input. So I am passing this epsilon to reach 1, 1 to reach 2. So this is where this OR operation begins, and 1 to reach 5. So either 1, 1 or 1, 0. Now as you all know, this state 1 is state 2 is taking this 1 to reach 3. Again there is a 1 to reach 4 and reaches 8 with the epsilon. So or 1, 0 to reach 8. So finally we have state number 9, which is called as a end state. Now say for example here 1, 1 plus 1, 0 the whole star. This operation is completed. We are going to complete this star operation. So here 1, 1 plus 1, 0 need to be executed more than one times. So I am taking this state number 8 to reach 1 again to execute 1, 1 plus 1, 0 by using this epsilon. Suppose assume that 0 state need not to execute 1, 1 plus 1, 0 to complete it directly to reach the end state. So 0 is taking epsilon to reach 9, state number 9 as an end state by using the epsilon, so that we can avoid executing 1, 1 plus 1, 0, the whole closure, that is the whole star, right? This is the step number 1. Let me take you to the step number 2. Step number 2, you can see here I have constructed a table, and the table is construction of by using the regular expression to NFA. Now NFA to DFA construction has been placed. Now I hope you can able to see exactly the diagram what we have been already drawn by using the regular expression. Now forget about this A star, just assume that X is mentioned here as a starting state. This is the starting state. We don't know what are all the other state here, right? So X is generally mentioned here as a starting state. Now Y is equal to E closure of X. We are going to find, take this state 0 and find out by taking this epsilon, state 0 is reaching which are all the other states. So we are going to find that, and lambda y comma 0 as an input and lambda y comma 1 as an another input, right? So let me project how exactly this X is taking. Assume that 0 is this particular X. Now we are going to take this 0 and we are going to use this closure, E closure, and we are going to find 0 is taking E closure to reach which are all the state possible, right? So 0 is taking E and it is reaching 1. So I have mentioned 1 here. And 0 has to be mentioned because it is the starting state. So I have mentioned here. So again I am checking that 1 is not stopping here. Again 1 is taking epsilon to reach 2. So I have mentioned 2 here. Again 1 is taking epsilon to reach 5. So I am taken 5 here. After 2 you can see there is no epsilon. After 5 you can see there is no epsilon. So after all this, 0 is directly taking this epsilon to reach 9. So I have mentioned 9 here. So the second column is also over. I hope you people understood. The next thing, I'm going to find lambda y comma 0. So these are all the y we got already. We are going to check which are all the state here present here is taking 0 to reach another state. Now check, 0 is not taking 0 to reach any other state. There is no. And 1 is not taking 0 as an input to reach any other state. No. And 2 is not taking 0 because 2 is taking 1, not 0. So no conversion here. And 5 is not taking 0 to reach any other state. And finally 9 is not taking 0 to reach any other state. So I have mentioned here it as empty set initially, right? So again I'm checking the same states, that is y comma 1. So any state here is taking 1 as an input and reaching any other state. So 0 is not taking 1. So you can see here 1 is not taking 1. And here you can find 2 is taking 1 as an input and the destination state is 3. So I mentioned 3 here. And check 5. After this 2 I am checking 5. 5 is taking again 1 to reach the destination state called 6. So I have mentioned here. And 9. So here it is 9 left. 9 is not taking any input to reach any other state. So there is no reachability. So I am stopping exactly here. We got a new state here. Exactly, you can see here we got a new state. The state is 3, 6. So I am jumping into the next state, that is 3, 6. I hope you can able to see how exactly this new state has been begun. Whenever the new state you got, you need to take that and find what all the other possible new states you can find, right? So I am taking it with the same example. So I am taking this 3. So I am taking the closure. 3 is here. You can see there is no E closure to reach any other state. Okay. I am taking 6 here. 6 is not taking any E closure to reach any other destination state. So 3 and 6 has been mentioned because it is a E closure. So I am mentioning 3, 6. Now let me take it to the next process. So that is whether this y, now 3, 6 is y, you all know that. Whether 3 or 6 is taking 0 as an input to reach any other destination path. So let me show you. So 3 is taking, here you can see 3 is taking 1. So no possibility. So again I am checking whether 6 is taking 0. Yes, it is. You can see here 6 is taking 0 to reach a destination called 7. So I have mentioned 7 here. And let me take you to the next part, that is lambda y comma 0. Y, you know that 3, 6 is y. So now you can see here this 3 is taking 1. You can see here this 3 is taking this 1 to reach 4. So I have mentioned as a 4 here. Now let me check whether 6 is taking 1 to reach any other state. There is no. So nothing is done. So I got 2 new state here. Number 1 is 7 and number 2 is 4. I hope you people understood how this 7 and 4 has been considered as a new state, right? So let me take you to the next level. So I am going to show here the new state 7 here. Find the E closure for this 7. So you all know that 7 is exactly starting here. You can see that. So 7 is taking E closure to reach 8. So I mentioned 8 here. And 7 itself. So I mentioned 7 here. 8 is taking E closure. This is also an E closure to reach 9 here. So I mentioned 9. And 8 is taking E closure to reach 1 here. So I mentioned 1. 1 is taking E closure to reach 2. And 1 is taking each closure to reach 5. So these are all the E closures of 7. I hope you people understood. Now you can see here exactly this 879125 as y comma 0. Right? Y comma 0. I hope you all know that how this y comma 0 is happening. The previous steps you can able to remember. Now this 8 we are going to check whether 8 is taken the input called 0 to reach any other state. So 8 is not taking any other taking 0 to reach any other state. 7. So 7 is not taking 0 to reach any other state, so it is also nil. So 9 is not taking any other input called 0 to reach anywhere. Okay, 1 is not taking 0 to reach any state, and 2 is not taking 0 to reach any state, and 5 is also not taking 0 to reach any state. So I have mentioned this as empty state, right? So now I am going to check again y comma 1. So here it is y comma 1. So now I am going to check whether this y is taking, this 879125 is taking 1 to reach any other destination. Now you can check it here. So 8 is not taking 1. So 7 is also not taking 1. And then 9 is not taking 1. And here you can check it, 1 is not taking 1. But 2 is taking 1 to reach 3. So 2 is taking to reach 3. So I mentioned 3 here. And 5 is taking 1 to reach 6. So I have mentioned 6 here. Don't bother about the repeated state. I'll tell you what to do if you get the repeated state again and again, right? So first state I have taken here as 7. And the next state, new state, we have 4 here. 4 is also taken here. And now you can check it. 4 has been taken. And finding this 4 for E closure. So where is 4 here? You can check here. So 4 by itself, so it is 4, it is a E closure state, and it is taking E closure to reach 8. So 8 has been mentioned. So 8 has been taken here to reach 9. So you can see here 8 has been taken E closure to reach 9. So mention 9 here. From 8 is taking E closure to reach 1. So you can see that in this diagram. So it is taking E closure to reach 1. Again 1 is reaching 2. And 1 is reaching 5. So all the E closure has been done here. So this 489125 is y. So we are going to find lambda y of 0 and lambda y of 1 for this particular E closure, right? So now we are taking this 4 and we are finding 4 is taking any input called 0 to reach any state. So 4 is taking only epsilon. So 4 is not mentioned over here, right? So 8 is not taking 0 as an input, and 9 is not taking 0 as an input, and 1 is not taking 0 as an input, and 2 is not taking 0 as an input, and 5 is also not taking 0 as an input. So it is a empty set, right? So let me jump to the next part. So here I am taking the same y comma 1. So 4 is not taking 0, sorry, 4 is not taking 1, 8 is not taking 1, and 9 is also not taking 1. 1 is not taking input as 1 to reach any state. Now you can see 2 is taking an input called 1 to reach 3. So I mentioned 3 here. Again 5 is taking 1 to reach 6. So I mentioned 6 here. You can see 2 repeated steps here. This is the same state. So if you're getting the same state, don't bother. Just wait and see the last step, how to avoid this repeated of steps. So you can see I have taken all the new states except the empty state. So you can see here the empty state is here. Here it is an empty state. Here it is an empty state. So finally, after completing all the new state, I am taking this empty state here. So if you find this empty state, you will get empty in E closure, you will get empty in y comma 0, you will get empty in y comma 1. So for a very particular reason, this state has been set as empty state, right? Now still the step 2 has been continued. I have taken all the new states here, and all the new state has been mentioned with a name. You can see here 0 I have mentioned as A, and 3 comma 6, that is a new state, I have given a name as B, and 7 is a new state, I have given a name as C, and 4 is a new state, I have given a name as D, and empty set I have given it as E. So now you can see here in this diagram where exactly which state is a end state. End state is a 9. So here wherever you find a closure part here 9, whichever closure you got 9, that particular state will be considered as end state. So A is a name. Here you can find E closure 9. So I am mentioning A as end state. Wherever the 9 you find in this particular E closure, that will be mentioned as end state. So here you can find 9. So I'm mentioning the C as end state. Here you can find 9. So I'm mentioning D as end state. So here it is an empty state, right? So let me take you to the next part so that we can construct the simplest form how exactly this NFA to DFA conversion has been done. So these are all the new state. So let us assume it as a Q. These are all the epsilon closure values, that is 0 and 1. So now you can check it. A star, that is A asterisk, is for 0 new state, and B is for 3 comma 6, C for 7, D for 4, and E for empty. Now you can check it over here. So now you can find exactly the 0 and 1. So now I am going to rewrite the same table here. You can check it. Rewrite the same table here without using this e-closure. Right. Now by using this state called A asterisk, that is 0. A asterisk, by using this, what is the input you got is empty, and another thing is 3 comma 6. What is empty I have mentioned? Empty I have mentioned as E, and 3 comma 6 I have mentioned it as 3 comma 6 I have mentioned it as B. So that is what I am going to write here. So 0 is empty for this particular state, and for this particular one I got 3 comma 6. So 3 comma 6 has been mentioned, named here it as B. So this is way I am going to construct this particular table. Now B, that is a new state here. So B is taking this 0 to reach 7, right? So I have taken the 0 and I am reaching 7. What is the name of 7th state here? You can see it is C. So I have mentioned it as C, right? So again I am taking this B to reach 1. So what is the 1 here? I got 4. What is the state number, name of the state which I have mentioned as 4? So you can see here we have mentioned D. So that is what here. You can check it. Now going to the next part, that is C. C is taking 0 and it is got empty state. You can check here. It is an empty state. So empty state, you know what is the name of the empty state? That is E. So I am mentioning it as E. And taking C is taking 1 to reach the new state. The new state is 3 comma 6. So 3 comma 6, you know what is the name of 3 comma 6? That is B. So I am taking B here. I hope you understood exactly the same path where exactly the C is traveling. Now I am taking D. I am taking 0. So again D is taking 0 and we have got empty. So as you all know, empty set, we need to mention it as E. So because we have already mentioned the name it as E. So again I am taking D to 1. So D is taken exactly here and it is reaching 1, and what the new state we got is 3 comma 6. So the name of the 3 comma 6 we have already mentioned it as B. So you can see here B is there. So E is empty state. So you all know what is the empty state here. E is taken 0 and it is reaching empty. You can check here. E is taking 1 and it is reaching empty. So the name of the empty state is E. So I have mentioned in this particular way. I hope you understood how exactly it has been done. Right. Now check. There is a repeated states here. EB, EB, and here also EB. And also there is a coordination here. You can check it. All the end states A, C, and D can be rewritten, right? Can be given a one specific name like this. Like say for example, P of A, comma, C, comma, D. So all this ACD can be replaced into P because A, you can check here, A is having EB and C is also having EB and D is also having EB. So why this repeated step? So we are taking all this as one. So we can reduce this transition table. This is the minimized DFA. So anything you minimize 5 into 4 or 4 into 3 or 1, whatever it is, that will be considered as a minimized DFA. Now check it here. Instead of taking A, C, D, I have taken it as P. So P star, that is P asterisk is mentioned as for end state. We have EB. So this P has A, C and D. So remaining part, you know, B have C and D. So this C, you know, what is the rename for C? We have to mention this as P. And D also we have renamed here. This renamed value is P and C also renamed value as P. So I have mentioned it as P. So E, you know very well, I have taken the same step and I have written here, right? So let me take you to the final step for this particular diagram. So you can check it over here. This is the state transition diagram. This is a state transition table. Take this table and draw here. So as you all know, P is the end state. So I'm mentioning it as end state. We have one more state called B, and next state is E. So P is taking 0 to reach E. So P is taken 0 to reach E. And P is taking 1 to reach B. So P is taken 1 to reach B. So this part is over. And let me take you to the next second part. B is taking 0 to reach P. So B is taking 0 to reach P. Again B is taking 1 to reach P. So 0 comma 1. Same destination. So 0 comma 1. Finally, E is taking 0 to reach E and E is taking 1 to reach E. So E itself 0 comma 1. So all about this particular explanation is how this conversion is directly made and what are all the steps we have taken to convert that into DFA directly. Thank you.